Hello everyone, welcome to the Open AGI Forum. I'm Eric Wang from CSDN, and today live from the GoSim China 2024 in Beijing. We're honored to have Gary Bradski from OpenCV to join us. He's got plenty of legendary experience to share. So welcome Gary. Please take a brief introduction of yourself.
Thanks. I'm Gary Bradski, founded and still run OpenCV as a nonprofit. I've done a lot in the tech field, from being on the winning team that started with Stanley, that started autonomous driving and a lot of robotics. I've done a lot of startups and investments.
Thank you. So, thank you for joining me today, and let's start with clarify some basic concepts, because I still have some doubt of the difference and the similarity between human and the robotic special intelligence. So we know that blind individuals, they can identify shapes through non-visual means and convert the sense of the lens and form by touch and feeling, right? So while the process might seem rapid and automatic, so akin to Daniel Kahneman, he seemed to say a concept of system one. So it actually involves a complex set of automatic processes that have been on over time. And the robots, on the other hand, they have various sensors to perceive the environment and construct 3D models through algorithmic integration. So it seems like it's system two in my sight. So, and once Kahneman once found that the AI industry had misunderstood some of his psychological concepts, and so pointed out that system one is actually characterized by automatically rather than just speed, and that it encompasses complex representations and causal reasoning. So to believe that robots could develop a type of spatial perception that is as automatically and richly representative as human system one?
I mean, yes, I think we're both, in the material world, and material world's able to support this kind of perception. I think primarily the difference right now between robots and human or animal is that humans have a rich world model. You will see it when you dream. You're in a world, and actually when you wake up, the dream doesn't stop. It's still a dream. It's just connecting with external data sources. So this is a generative model of the world that's being matched with outside sensing inputs, and that's how we think we're in this, a 3D room that's approximately rectangular here, but we're only really seeing very tiny parts with our fovea. And you could consider this as kind of like prompts into a world model, that's generating a consistent world model. And if it doesn't match, we'll be in shock, or there'll be some surprise. But this is how we get a stable percept of the world. So right now, robots, technology hasn't really implemented a world model, or even it doesn't yet have a good way of doing this. And so, that's the primary difference. I think when, this Carmen, if you go down in the animal levels, they have, less and less explicit world model. Very simple animals basically have a kind of just an attraction or repulsion to stimuli, swim towards or swim away. But as we've grown up in brain complexity, we've turned into this world model that has causal prediction and stabilized for matching and being in the world. That's the...
I see. So where do you see the current technological bottlenecks?
For developing, AI in general, or world model. I said it. I think by itself, we don't have, there's not yet an elegant solution for developing a world model. People are trying. I think Feifei's new startup is an attempt at this, but we don't yet have an elegant way of doing a world model. And one of the problems with the deep net technology is that it has this property of catastrophic forgetting. So if you train a model, and you try to add learning directly to the model instead of on top of it, it destroys the data in the model. And this is completely opposite to humans that do continuous learning. And thereby humans learn simple facts that they build up to, to more and more complex facts. You can think of it as humans establishing a basis system and structuring knowledge, whereas deep nets, it's more like if you play bingo, you put all the facts in a big bucket and you turn it around and you draw them out independently, and that's not to bias the learning. And therefore, if you want to add any learning, you must add all the facts back in and redo the whole process. It's just too expensive. So if we can't do continuous learning, you can't really, I mean, you can, there's ways of getting around it, just like we've got to around this with language models, but you can't truly do a world model. Why? Because you have to keep learning. The world keeps changing. New parts of the world are added. Even this room gets shifted around, the chairs move, eventually the carpet gets changed. And so you have to do continuous learning in order to do a world model, but for many other things. And so I think that's, those things, this catastrophic forgetting, continuous learning is one of the fundamental things that is not yet solved.
Yeah, so from OpenCV side, so what are the key steps or what we do to involve in transitioning a research idea in spatial intelligence into a viable product?
Okay, very different question is, okay, how do we make a business now? And I mean, I guess everybody has different philosophies. I've had some success in businesses. I try to, to get real as fast as you can, like see the customer involvement and also keeping things simple. Like, OpenCV grew up where there was already several other image libraries, but they were complex C++ class hierarchies, and I just said, look, all I want is a function, you call it, it does something. It's very simple, right? And it won out, and there's lots of languages that are more elegant, but Python is sort of dominating, like at least in AI. And it's not because it's a great language, but it is pretty simple to work with. And so, I would, if I'm looking at a business, it takes a lot of judgment. I don't know how to make a formula for having good judgment. My most successful investment was Lambda Labs, which is it's a cloud service company that's now mid-tier between the giants like Google and Amazon, and it's in the middle fighting it out. But I mean it's already profitable and it's worth a couple $1 billion. And the guy had a terrible business plan at first, but it was 2012, and I thought I judged him to be a good operator. Like he always turned things around, and I just bet on that and sort of guided it in certain periods of time. But I think he had a real sense for simplifying and staying up with the business, realizing that he just had it. Instead of being fancy with his theories and models, he goes, I just worry about the cost of a capacitor, like keeping the machines cheap, right? So I guess that's like being very practical. Is there really a market for what you're doing, which is hard, and you have to be very honest with yourself. And sometimes there isn't a solid answer. And then how do I approach this in a way where I can actually start getting feedback? Instead of waiting a long time, can I get feedback from the market? Can I put out something very simple quickly?
Yes, you have mentioned before in other interview, you have mentioned that creating OpenCV was driven by the desire to reduce duplication of effort and improve overall efficiency in the field of CV. So,
Yeah.
did you face any resistance or opposition when starting OpenCV? So, if so, how did you overcome this challenge?
Uh, I faced a lot of opposition. I wanted to add, I had a lot of goals for OpenCV. I was told the charter was for Intel, was afraid that word processors and spreadsheets, there was already enough compute to do them all. Why does someone need a new machine? And so I go, well, AI vision of infinite compute needs. And so I said, I looked at the field of computer vision and it was terrible. Everybody had their own code bases, impossible to do science, to duplicate someone's work, to see if they're even telling the truth, right? And so I thought, let's give everybody a good solid substrate. But I also wanted it for greedy personal reasons. Like I knew I'm not going to work for Intel forever. I wanted to take my work out. And so that had part of it. But I faced a lot of opposition. This was not, this was not an assignment. I wasn't told to do that. I just started doing that and I was threatened with being fired, many times. I just essentially, it's the equivalent of, I don't know, going in, who knows, Baidu and saying, going to the department and start giving them orders. I'm in a different group, but I go, no, here's what we're going to do. That manager there, don't listen to him. You're listening to me now. No, the CEO didn't say that, didn't give me permission. I just started doing it. I was potentially in a lot of trouble, but I kept having success. So I don't know whether I'd recommend doing what I did, but I was willing to take a lot of kind of the rebel risk, and it all worked out. There were several times I was threatened with being fired, and I mean the last time, like they said, for the DARPA Grand Challenge, the autonomous driving, they said, you're disturbing groups, other people want to join you, and they're not doing their work. This is like firing a fence. And my boss, he's yelling at me, and I go, okay. And then I walked away and I go, I'm no longer doing any work but the autonomous driving. I'm going full speed ahead. And so some people dropped off because they were afraid of getting fired, but the group that stayed, sort of revolutionized the world, right? It's a big risk, and I don't know that everybody takes risks or can take risks so well. It's part of my personality. It's not like I decide to do this, I can't do anything else.
So to the challenge now, this day, because you have saying you wanted to organize a new type of robot competition, focusing on real-world tasks like planting foods or repairing roads, and you have an example of FIRST. Yeah, I actually did complete in FIRST. I'm 24 now. Yeah, and I built a robot with my classmate in my junior year in the first competition. It's all for teenager, right?
Yeah.
So, but they put all the rules and instruction on GitHub, so which was hard for us at that time because our junior school didn't teach how to use GitHub.
Yeah.
So the question is, what elements do you think should be included in the design of such competition? What specific goals do you hope to achieve through this competition?
OpenCV actively runs competitions. It's really a matter of funding. I would like to do more and deeper competitions, but we need the money to put out, to get someone to judge it, to organize it. So we do this as much as we can when we find sponsors. But my idea for doing this is, why not do things that are more real? So you can have a competition, I'm running robots around and they're putting teacups away. Like, who cares, right? Or I'm analyzing images on the web. It's just like, it's been done, and what difference does it make if you succeed? So I thought, why not have competitions that, and I still haven't done this as much as I want, but let's say autonomously growing food, or just plant data so we can know how to adapt plants to climate change, like a cheap way of maintaining a field so that we can have thousands of test plots testing plant varietals for how they're adapting to climate. Today, this work is mostly done by hand, and so it's not done much. It's expensive. A group of trained students or workers goes out and they have a little, they have 3 or 4 plots that they look and they analyze and they come back to a couple times a week. Why not have something autonomous? Can we have a challenge that is just monitoring food? And that would be something that's impactful, that would allow wider, let's say climate adaptation for plants. It could save billions of lives, right? It could be hugely impactful. So that would be a better challenge. Now, the other thing I say is, like, give people a decent substrate, like OpenCV was a common platform to build on. Not only can you help analyze the results of what they did if it's on a common base, but it also puts them at a higher level. Instead of everybody's reduplicating the basics. That serves no purpose, right? Have them compete at a higher level, and now you have it on a comparable basis. That's the key.
I see. Yeah, you talk about actually money problem, and once you mentioned that OpenCV needs stable funding, especially government funding, government support. So what's the current primary source of funding for OpenCV? Would you domain or collaborate with company?
It's not good. I think it's better in China. There's more support of open source. In America, it's like free for all. Like, just go survive. We don't care. If you die, that's too bad. If you live, great. But for the societal good, I wish there was more support. But what support there is comes from we going to companies like Google and whatever who will contribute. Now, I went to Facebook, but Facebook puts out open source, but they don't have a program for supporting open source. So when I went to Facebook, I got the manager and he goes, sure, what are you going to do for me? Like a contract. And I go, no, this is for the good of, it's not his charter. In Google, they do have more of, okay, we have a program for open source. We'll give you money for a workshop. They have someone who has that charter. And so I wish they had more of it. We are trying to get to a point where there are grants that the government has for calls for proposal that, you have to get used to writing them and a little bit known by the people. And so there are general things that we might try to go after. But right now it's really just asking for money, and that's why we're starting to do a workshop, and I want to put out this spatial intelligence platform that we'll charge for. The thing is, so it'll be not free and open, it'll be inexpensive and open. I'd say, what if it's $1 a month? Is that going to stop anyone from really developing? But it would get not a huge amount of income, but enough income where we can have a stable developer base. Because right now, every year we're going out, who's going to contribute? Can we pay the people? So we have a few core developers, which is important for the organization to have. And then we have a lot of contributors, but no one can even contribute to the library unless there is some paid developer at its heart saying that's good, that's bad, to say what goes in and out. But enough said. I wish there was better support.
So OpenCV has been instrumental in teaching computer vision to a wide audience. So can you reflect on the impact that OpenCV has had on education and training in the field of CV and robotics? What improvements or new features would you like to see in OpenCV to enhance its educational value further?
I mean, so OpenCV, one of the things it does, and it is for money, is it has this OpenCV University, which covers a lot more than OpenCV. It mostly is focused on PyTorch, AI, generative networks, and a large section on OpenCV. And then that does pay at least $100K a year back into the organization, which supports the developers and whatever. The courseware is also expensive, but for education, I mean, one of the things I want to do is tune up one of these language models that, especially on OpenCV, so that you can just chat and ask it. Get all the OpenCV code bases, so you can ask it, well, how would I solve this problem, or you suggest an operator that would work here. I would like to see that. We're releasing OpenCV 5.0, which is just bringing everything up to a higher C++ standard, the 17, version 17. So things are a lot more coherent, a lot more optimized, and I think, I guess the simple way of saying, we now have more of a focus on embedded devices, so I think that's fun and interesting. The students can get something that works, that doesn't need a giant cloud and whatever. You can buy some parts and have something do something. Yeah. I think that has the potential for a lot of interesting projects of machines that see and maybe do something.
I see. Does OpenCV complement or compete with other tools and libraries in the field of CV?
I mean,
how does?
For classical computer vision, I don't think there's much competition left. We have many that have competed, and they haven't endured or survived as much. Yeah. But PyTorch and TensorFlow and the other libraries are, eating language, vision, and whatever. So we focused on this DNN, the Deep Neural Network module, and just trying to get the inference to be very simple and optimized, so that 2 lines of programming you get. I showed in my talk, like a face detector or some other AI functions, just in very simple lines of Python code. So we're riding on top of other success. Partly of this AI toolbox, the spatial AI toolbox I want is, again, a very simple framework for having AI that's situated in 3D.
Yeah, that's the question I want back to the AI topic. So you have made a presentation about how humans learn through structured curriculum while AI relies on random sampling.
Yes.
So leading to catastrophic forgetting. That's the words you use. You suggested that sleep and biological learning mechanism might hold the key. So building on this, could you elaborate on why you believe understanding biological learning mechanism, especially sleep, is crucial for AI development?
Well, I'm just saying there's this fact that there's neural networks experience catastrophic forgetting. That is, you train them up by this identically distributed, all facts are equal, and it's not a way you learn. I don't teach you 1 + 1 is 2, and then something about quantum physics, and then something about the biology of newt eyes. That you would just go crazy, right? But you basically build up, I think, a basis vector for structuring knowledge, and so it's a very different learning system. And in that system, humans are able to be lifelong learners, but they all sleep. All biological animals sleep, and so I believe that's because sleep is so dangerous for an animal. You're unconscious. You can't respond. You can't defend. You can't flee. It must be that there's something fundamental about learning, about structuring learning, that you can't get away from some kind of down cycles where you reorganize the knowledge. It seems like that might be a mathematical certainty, and I can think of ways of approaching why that might be. And I think it is that in animal development, we go through these phases where you can learn some things and then they become fixed. And for instance, if you grow up and you don't see any vertical lines, after a critical period, you can't learn it anymore. And why would that be? Because the learning has to form some kind of basis structure for actually representing knowledge. And so you want a few things fixed, and then you build the next level and on up. And I think sleep might be the same thing. Like basically cleaning up out of distribution noise from the system. It might be fundamental. I mean, there's no proof, but it seems like, well, why wouldn't something learn not to sleep and eat everything else?
Yeah. Is there any machinism? I mean, if we want to design an AI system that more closely mirrors biological learning mechanism, where should we start?
So it's hard, like right now there's a lot of success. You get an LLM, tune it, and you're a hero. And versus you go, no, I'm going to restructure the whole thing. Probably you're just going to be a fail, right? So again, it takes some kind of brave student who, has the means that they won't get crushed by failure. But I mean, I suggested that it's kind of in building world models, and the simplest one is SLAM. If you have a system, simultaneous localization and mapping, it means the robot goes around and it learns the map as it goes and it uses it. Well, if it's going to continue going around, just focusing on the map, it has to keep learning, because the chairs move, some things move quick in an environment, some things move slow, and there's people, and you have to learn and keep learning. And just using that as the paradigm problem might be a way of thinking about, the need for the ability to learn always. It's clear we have some things, like we only learn on mismatched expectation. Like if you're stepping on a floor and there's a hole, suddenly you go, wow, you learn there's a hole there, or you break your ankle. But and so it's clear that there's a mechanism in biology where it's not really turning on learning. You're just bored, or you go, okay, you're not learning anything, and you go, oh, something that's unexpected, that's new. I now have a learning signal. So, deep nets, they're just learning all the time. They don't have a mechanism. You could think about how to put that mechanism. Clearly, sleep is still there, so it's not enough just to have that mechanism. There's something else going on. Right?
I see. Yeah, I have an interesting question. Yes, throughout your journey developing OpenCV and studying computer vision, what aspects of human visual or animal visual learning have surprised you the most?
I mean, once you start learning about the visual system and whatever, and you see a little fruit fly, it's just astounding what it can do in so little. I mean, that's a surprise. But I think one of the surprising thing is just how different even animal systems are. You might, you might people show their cat a video, isn't that cute? But cat's visual system reacts faster, and so videos might not look like videos to a cat. It might look like someone holding up cards.
Sentiment animal like dog have colorblind.
All animals have. Humans have a very rich color spectrum. Birds have richer, but most animals have poorer. Some shrimp and whatever have the richest of all. And so you have to say, what are they seeing in the environment? And like a cat is meant for nighttime, dim vision, and so bright colors make no sense to it. but also it's meant for fast motion, and so when you show it a video, it's not seeing the colors very much, and it looks like cue cards probably to it. You know, it doesn't look like motion. So you think, aha, look at this, my cat's seeing another cat. It's not. It's seeing frozen pictures of, you know, of a different sort of thing. So I mean, I guess being aware of these differences of perception is one of the surprises, right?
I see. So, from your personal perspective, which emerging research directions in bio-inspired learning so to find the most promising? I mean, besides of CV, yeah.
You know, I don't know if anyone is really taking this catastrophic forgetting as something that's fundamental.
Wow.
Yeah, but I mean, of course, you know, Jan LeCun has papers on intelligence, and he's big on world models, and he's proposing one of the problems with the world models, how do you connect up different sensing modalities into a whole? And so he basically proposes this energy, basically you could think of at a high level as it turns things into a scale or a value, so they can talk together, so voice can talk to vision in these different, you know, to meld these world models. And so, you know, I think that's probably a promising direction. There's some more obscure researchers. I'm not even sure I want to say their names because it might be a complete waste of people's time. But, you know, my friend Rodriguez has been thinking about, you know, how you get Hebbian. Right now we have gradient learning, but there's a Hebb learning, which is by correlation learning, which is maybe more biological. And he's thinking, how can you build as rich machines with Hebbian learning? There's probably a lot of people thinking you need like different areas of thought, because he might not succeed, but sometimes they do succeed, and then everybody, it causes a revolution, right? But a lot of these people, they kind of have to be self-driven. They're just fanatics, and most of them fail because it doesn't work, but occasionally it works, right?
Yeah. Can you exactly describe what is the what's, where, why system? Because it's a little bit different with the Fei-Fei Li.
Well, I mean, Fei-Fei Li is trying to basically build up this world model, but in humans, or most animals, mammals at least, they have you can say a kind of separate circuitry for what and where. What is humans are in the room, chairs are in the room, but where are they? They're at this coordinate. And it does seem those channels they're blended, what's called late. They're not learned together. You don't have human there, but you have human. And so, I mean, the simplest way of doing that, which is what I'm proposing, doing the simplest way, is I have my AI models here, and I have a 3D system here, and they're able to talk. So any image, like from a camera, can say, where am I? And it'll say, you're here. And it can say, what is there? And I go, well, there's two humans. One is there, one is there. Yeah. Now, why is a way of, what humans also do is they model the causality of the world, or another way of saying the physics of the world. And so, you know, it's not just what and where, but I have expectations. You're not just going to float off the ground, and there's gravity, and so there's a causality. If I knock a bottle off the table, it's going to fall on the floor. It's not going to fly up. So that's a why system, which maybe could be in a what, why, and where. I don't know biologically exactly like where this world model forms, but it is part of the world model, right?
I see. So, as someone who has been deeply involved in the development of AI technologies, what are your thoughts on the ethical implications of deploying AI-driven robots in public spaces? So how can we ensure that the systems are used in responsibility, you know?
Well, maybe they won't be.
Classic
I mean, cars are a case, right? They're
Yeah.
already driving around, and like, how do you know it's going to not crash, or that the car maker wants to deploy their car, and if someone crashes, if you don't punish them, then they go, well, it cost us to prepare more. We'd rather just put the stuff out there and let people die. Is not ethical, right? But obviously, there's privacy concerns, and so that I guess have to be thought of in a well-rounded system. In the States, there isn't. They have regulations, so you have to get approval. But a lot of things in the U.S. are just done by legal. You just sue. So, lots of lawsuits, and so if they're a little afraid of lawsuits, that they won't do it. But to deploy systems. But a better way would be is if you made a rule where any event that isn't normal that a car experiences should be reported to a common database. And then you could say, before you deploy new software, you have to drive in simulation with passing all those situations and the new ones that are accumulating before you can deploy that into the real world. You have to drive, let's say, 1 million miles without avoiding situations that we find. And before you release something new, I would do it that way.
Yeah.
Everybody has this, because each company would rather own their data because they have an advantage. But you go, look, for a safety reason, all that data should be collected in one spot for any car or vehicle to learn from and have to pass that standard.
Okay. So let's switch the gear. So what are some of the achievements you're most proud of, and why do they hold special significance for you?
Some of the achievements are just happen like randomly because I've had adventures. Like Sebastian Thrun came by and said, "You should join me. I'm going to do the DARPA Grand Challenge." And I go, "That sounds like fun. Let's do it." And so I was on the team and we won. The first year it had failed, and then the Stanford team started the second time in 2005. And it was a great experience. He was a great leader, and I especially joined Sebastian's team because Red Whitaker at CMU is an excellent roboticist, but he actually came from the military, and he's like, "You do this, you do that. Here's what you do, and stop that, do this," and very command and control.
General.
Whereas Sebastian was like, "See if you can keep up with me. I'm coding all night. You should code all night and all morning." And so it was a much sort of nicer, looser style of more like a shame if you don't keep up with this team. And I decided to join his team just to show that the softer approach can work. You think the strong general wins, but also, the distributed team that's pretty happy can also win, and so we did, and I'm proud of that. And it sits in the Smithsonian Air and Space Museum. That the car is there. I've gone in the museum and just started lecturing on the robot, and I got this big crowd. I'm like, so that set off a whole industry. But OpenCV, of course, helped. Very few things you do in life actually work out. And OpenCV, I wanted to help accelerate the industry, give people a common platform, and it basically all worked. It's kind of shocking because most plans don't work, right? So that and some of the entrepreneurial stuff that I've kicked off. I've done medical stuff. I've Lambda Labs, and now I'm doing something in space and agricultural robots. That's what I like.
Yeah. So, is there anything you believe essential very important for young professionals entering the field of AI and robotics?
Yeah, I mean, I think.
Or lessons?
Well, I mean, people tell other people like, "Oh, you should network, and here's how you network." I don't know. I just network because I'm actually like fundamentally interested in everything, right? So I'll talk to people. How does this work? How are you doing this? Because I'm actually interested. I'm not trying to build a network, but because I do that, that is one of the things that has helped me the most. Like when I have a problem, I go, well, actually, I know someone who knows someone who can solve that problem, right? And so I'd suggest keeping a wide network, but some people like to just focus in, and that can work for them. For me, it's like networking. It's also a distraction, right? I'll go to an archaeological site and I'll ask, well, how's this? How do you know that? And it has nothing to do with my work, right? I just network all the time because I'm actually interested, right? So I think that's a big one. And then I guess, try to step back and take a wider view. Like, don't always, I mean, it's very easy to do me too. Like, what should you do? Oh, tune up an LLM. I go, well, maybe you should think more fundamentally and do something, maybe revolutionary, but it's at a higher risk. I tend to be someone who takes the higher risk, right? Because I guess I never had the fear of failing. I figured I'd always be okay because I knew enough tech. So if I get fired, which I've been fired many times, I'll just find something new to do, right? But
Find something new to do.
I go, oh, well, if this doesn't work out, something else. Even on this trip, we have, what's ticket to go? Because these organizations are interacting. I go, I don't know where the train ticket is. And my wife would say, what are we doing? I go, I don't know. Someone will tell us. Or we'll be stuck at the train station and have to figure it out. I don't know.
I see. So I think there's other questions, Gary. Thank you for the insightful discussion.
Yes.
And thanks to all the developers watching. And that's all for today's podcast. See you next time.